All right, so special right triangles. There are certain properties for special right triangles that we're going to go over today, and it's kind of like a puzzle. So it may be a little confusing. I want you to stick with me, but really start to think of with a puzzle, you use a little bit of information to get to the next one, right? And then you use that information to get to the next one. Almost like a scavenger hunt, I guess, more than a puzzle, but it's a little challenging and it's pretty fun. I think it's really neat. So we'll see how this goes and see if you guys agree with me on what's fun or not. But anyway, so special right triangle, 45, 45, 90. Think about this. If these are both 45 degrees, then whatever they're pointing to is going to be the same, right? So these are just like the isosceles triangle property where we have two angles that are the same. That means that their opposite sides also have to be the same. They also have to be congruent, right? So that's what it says over here. The legs of a 45, 45, 90 triangle are always congruent. We have that because the isosceles triangle theorem. So we're just going to call those X. Now, if we have those two, we can find out what the hypotenuse would be, right? So I would take a squared, x squared, plus b squared, another x squared, equals c squared, right? And then from there, that would be 2x squared equals c squared, right? And if I'm solving for c, I'm solving for this hypotenuse, I'm just going to square root both sides, right? Well, the square root of 2, I can't do anything with it, but the square root of x squared will just leave me with 1x on the outside, and I'm still left with that square root of 2. So that's where we get this x square root of 2. So it doesn't matter. X is a placeholder. It doesn't matter what length that is. I could say that the legs are 10, and then the hypotenuse would automatically be 10 square root of 2. I could say that the lengths of the legs are 5, and the hypotenuse would automatically be 5 square root of 2. So it's a really quick, easy way to figure out sides of a triangle. But these are special cases, right? This only works with a 45, 45, 90 and the 30, 60, 90, which you'll see in a second. But I think you'll see this is actually pretty easy. So if this is a 90 degree, if it's a right angle, and we have 45 degrees here, that means this one's got to be 45 degrees, right? So that means that these two sides are congruent, and if one of them's 8, that x has to be 8, right? And then from there, to go from a leg to a hypotenuse, we pretty much just tack on that square root of 2, right? So we're just multiplying by the square root of 2. So that'll be 8 square root of 2 automatically, right? You don't have to do the Pythagorean theorem. You don't have to do any extra work. It's a quick, easy way to do this. And this is really important when you get into pre-calc calculus. We'll show you why this works and apply it to the unit circle and trig, all sorts of stuff like that. We'll get into it in Math 3 as well. So for number 2, same thing, 45 degrees. So we know that that's 45 degrees because it all adds up to 180. We know that these opposite sides have got to be congruent, so that y is 25. And then that means that x, to get to the hypotenuse, we just take that 25 and multiply by the square root of 2. So that's 25 square roots of 2. Really simple and easy. But sometimes we can go in the opposite direction, right? So there we have 19. And with 19, that is the hypotenuse. So in other words, the hypotenuse is already x square root of 2, and we need to go back to x. So instead of multiplying by the square root of 2, we're actually going to divide by the square root of 2, okay? Now, hopefully you guys remember from radicals that we can't have a square root on the bottom, right? So we need to rationalize this and multiply it by the square root of 2 over the square root of 2, because this quantity right here is 1. So what happens here is just 19 square roots of 2 divided by 2. That's it. That's x. And if that's x, then we know that's also y. It's the exact same thing. So 19 square roots of 2 divided by 2 is your final answer. You don't have to divide out 19 by 2 and make that an 8.5. That's perfectly fine. Don't even worry about it. 9.5. Yes, 9.5, not 8.5. Jeez. All right, so we have the same sort of concept with a 30, 60, 90 special right triangle. So with a 30, 60, 90, this 30 degree angle is the smallest compared to the 60 and the 90, right? So that's going to be the smallest side, and we call that shortest, smallest side x. That's it. It's just x, just like the legs of a 45, 45, 90. Now, to go from that smallest side to the hypotenuse, all we do is double it. The hypotenuse is 2x. Okay? And then the longer leg, which is 60 degrees, that one is going to be x square roots of 3. I'm not going to take the time to prove that to you. I could. You can look up a YouTube video as well if you want to, if you're really curious. I mean, you got plenty of time. But I'm not going to prove it to you right now in this video. So for number 4, they gave us the smallest leg here. That's 30 degrees. So the smallest leg is opposite of that. So I'm just going to write these ratios just so that you can see how to get from one to the other. So this is kind of like your, I would say your like formula, your template on how to do this. And then we're going to move concerning it. Okay, I'll just kind of show you. So if 5 is x, how do I get from x to 2x? What did I do? I multiplied by 2, right? So to go from 5 to y, I'm just going to multiply by 2. That's it. Okay, so these ratios kind of show you how to get from one to the other. To get from x to x squared root of 3, what did I do? I multiplied by the square root of 3. So to get from 5 to x, I'm going to do the same thing. I'm going to take that 5 and I'm going to multiply by the square root of 3. Okay? So the same thing with number 5 here. They gave us the smallest side. I'm going to write my ratios in red. X, hypotenuse is 2x, longer leg is x squared root of 3. So they gave us 14. The easiest thing to do first is go to the hypotenuse, right? To go from x to 2x, you just multiply by 2. So that 14, that x is going to be 28. And then to go from x to x squared root of 3, you're going to multiply by the square root of 3. So we're going to do the same thing with 14 going to y. Take that 14, multiply by the square root of 3. Okay? Now, if it gives you the shortest side, that is the easiest. And hopefully you can see that because you just go from x to 2x and from x to the square root of 3. But it gets a little more difficult. Sometimes they might just give you the hypotenuse. Now, the hypotenuse is still not that bad because it's only 2x. So what I would suggest you do is not go this way, but instead go the other way. To go from 2x to x, that's easy. All I'm doing is dividing by 2. So 32 to get to x will be 16. Then to go from x to x squared root of 3, we're still just multiplying by the square root of 3, which is really not that difficult. Okay, so I'll do the same thing with 7. They gave us the hypotenuse, so I'm going to write my ratios. They gave us a hypotenuse to go from 2x, to go from 2x to x, we're just dividing by 2. And then to go from x to x squared root of 3, we're just multiplying by the square root of 3. So I'll take that 23 and tack on a square root of 3. Now, 8 and 9 are the ugly ones, right? These are the ones that don't come out nice and neat because they gave us the 60 degree side first. So this is x square roots of 3, right? The very first thing you need to do is get back to x. Every single time you need to get back to x. So what do I have to do to get from x squared root of 3 to x? I got to divide by that square root of 3. So it's a little ugly, but that's okay. 20 divided by the square root of 3. This just means we have to rationalize, which is really not that difficult. It just is a little ugly, right? So to get to y right there, that's going to be 20 square root of 3 over 3, all right? And then to go from there, to go from this x to the 2x ratio, all you have to do is just multiply by 2, right? So that's really easy to go from 20 square roots of 3 over 3 to 40 square roots of 3 over 3. And my iPad is freezing up, and I don't know if you guys can see this or hear me or not. Maybe the pencil died. The pencil might have died. You can fast forward about 30 seconds. I'm just going to sit here and wait. All right, and we're back from your commercial break. There is 40 square roots of 3 over 3. and all you're doing is multiplying that by 2. So for number 9, they really made it nice and easy for you, right? So that's 60 degrees. So this is the 60-degree side. I also want you guys to understand that I'm writing out these ratios, and, on that last problem, I was kind of thinking about it while I was waiting. It looks really confusing because of like the y and x, but understand that those are just templates of how to get from one side to the other. Those are the ratios. X could be any variable. All we're doing is labeling them. So to go from x squared to 3 to x, I will divide by the square root of 3, right? Which is really nice here because 9 square roots of 3 already has a square root of 3 in it. So to go to x, that'll just be 9. And then to go to y, we just double it, right? That's just 18. So hopefully you are getting a better hang of those. Obviously, special right triangles are not the easiest thing, but 30, 60, 90 is a little more difficult than 45, 45, 90. But with this little bit of practice, you should be fine, and you'll be able to get some of these really difficult problems down here.